I'm David Levine. I'm here to tell you a true story about how I was accused of covering up alien contact, and what my view from being the target of this conspiracy theory can tell us about conspiracy theories in general, and maybe you'll learn a bit about how we humans can be really bad at understanding statistics as well. In 1985, I worked as a contractor at Johnson Space Center on early design of the International Space Station. This fact is going to come back later. I was just fresh out of graduate school, and the other interesting thing about 1995 is that this was around the time that the World Wide Web really started to take off. In late 1994, I had started working on an idea for a game on the web. Uh, Previously, I had done a few kind of silly interactive projects during the year, but I wanted to do something a little bit bigger. And so I decided I wanted to create a game about SETI. Now, SETI is an acronym for the Search for Extraterrestrial Intelligence. Typically, this means using radio telescopes looking for signals that are either purposefully directed at us from aliens or that we may just be overhearing and then trying to decipher them. You might know SETI from SETI at Home, which was a project from the University of California at Berkeley. They created a screensaver that you'd run on your computer to help analyze radio signals looking for messages. Basically, they were crowdsourcing the software analysis, and it ran from 1999 to 2020. Also, there was the SETI Institute, was NASA's official partner in the search for extraterrestrial intelligence until 1993. And then there's also the SETI League, which is a grassroots organization that's focused primarily on education. They do run their own search now, which is called Project Argus. The other thing I kind of wanted to point out is, that I thought a message from aliens would be kind of a fun puzzle. A lot of scientists have proposed, the interstellar travel is too difficult and requires far too much energy for it likely to ever be practical for anybody, human or alien. So they propose that we're likely only ever going to encounter aliens via long distance communication. And to that end, there have been a bunch of projects over the years listening to the stars with large radio dishes, sometimes even optically viewing stars for like laser like signals. Um, like I said before, we might overhear sort of normal radio chatter, or we might hear a message that's purposefully sent out. Um, we don't expect those messages to be spoken, not radio the way that we kind of think of it, like morning radio, normal AM, FM bands. What we listen for is across a lot of different frequency ranges, and a lot of thought experiments have kind of gone into thinking about how these kinds of messages might be structured to be understood when we have no common language with them. These two books that I'm showing you here, The Listeners by James Gunn and Contact by Carl Sagan, famously both tackle these questions as well. In fact, Carl Sagan had said that Contact was at least partly inspired by The Listeners. They're both really good books. In both books, messages are sent as a simple series of on-off tones of equivalent lengths. So you can assume that the on tone is a 1, and the off tone is a 0. Ones and zeros, I'm not talking about computers. It's just the simplest way of us thinking about the contents of that message, which would be on and off. Like that's the simplest way to have a message. Signals on, signals off. So because we're not really talking about computers, and so I don't want you to get confused thinking about these ones and zeros this way, let's replace them with something else. We can use stars and dots. We'll use dots for the zeros and stars for the ones. This might help us see a little bit more easily if there's a pattern. So, well, not really. It's kind of hard to see if there's any pattern in there. So how would we know what the contents of this message actually mean? So what both Gunn and Sagan popularized was the idea that the length of the message would be an important first piece of information. So in my example here, the length of this message is 49. There are 49 dots and stars, or 49 on-off tones. So what's special about the number 49? Well, it's only divisible by 1 and itself, and 7. And 7 is a prime number. So 49 also is 7 squared, which is kind of interesting. So we might try arranging the on-off tones in a 7 by 7 grid. And when we do that, now suddenly there's a pattern. It's a very low resolution drawing of a circle. So there's no special encoding in those on-off tones. We just line them up and we look at them. So with a string of tones long enough, we could create quite complicated drawings that could allow us to send all sorts of information. What if we received, for example, a message of 2,098,997 on-off tones? Well, that number is a product of two prime numbers, uh, 1,931 times 1,087. So we could arrange that message in a grid of those dimensions and we'd get a nice full HD frame. We even sent out our own message based on this principle back in 1974 in the direction of the Hercules globular cluster of stars, which is about 25,000 light years away, meaning it'll be 25,000 years until the message arrives there. The color is added here to help you identify different parts of the message, but the actual message is just on-off tones. There's no actual color that's transmitted with it. So the message, if it's studied by mathematicians and scientists, would reveal numbers and information about atoms to start as a kind of calibration. We're not really teaching anything, just making sure that we're on the same page. If aliens can understand that, then they understand a base 2 number system, ones and zeros. You can see an image in the middle there of the DNA double helix. There's a crude drawing of a human with a population count and a height, which is measured in units of the wavelength of the message, a diagram of the solar system that includes Pluto, and a diagram of the radio telescope itself, which transmitted the message, which was Arecibo in Puerto Rico, which sadly no longer functions. So anyway, let's get back to the game. I created these messages to be decoded. I wanted it to be hard, and I wanted to show that even an alien that created a message that it wanted to be easily understood might be open to misinterpretation. So I thought that I should create a fairly simple message, similar to the message we just saw. It would start off with some very basic math and science that we already know, but the idea was to give it kind of a weird way of thinking. So I didn't, and I didn't want to use that image format that we just looked at. It's really too well known. Instead, what I wanted to use was more kind of a raw sort of message, which would require more than just an on-off tone. So what I decided was I'd need a variety of frequencies for different tones, and each tone would represent a different number or symbol, like plus, minus, equals, or perhaps symbols to represent various types of atoms, things like that. But I said I wanted it to be presented in kind of a weird alien way. The idea is that, again, the aliens want to be understood, but they're hard to understand, if that makes sense. So I could list, for example, a bunch of math statements, and the tones that represent them you would figure out eventually because you would have enough examples of those tones, and eventually you'd figure out what they mean, like that this tone must mean one, this tone must mean plus. Um, but again, I wanted to make it alien. So the first thing I thought of was, well, what if I wrote everything backwards? So instead of 1 plus 1 equals 2, it'll be 2 equals 1 plus 1. But I thought, well, that's kind of going to be too simple, not weird enough. So instead, what I decided to do was have the alien grammar, so to speak, be symmetrical. So whereas we typically read from left to right, like these math statements, the alien math statements would read from the outside in. So you can see the alien equivalence here of the way that they would write 1 plus 1 equals 2 would be two ones on the outside, a plus symbol, and then 2 in the center. That's where the sum goes. And on the next line, I have 2 plus 3 equals 5. 4 times 7 is 28. And then this last one, I just wanted to point out is kind of interesting. It's a way to start introducing other symbols. So if I said 1 plus 1 equals 3, false, and if I did enough examples like that, showing you ones with true and showing you ones with false, eventually you could figure out what those symbols were that meant true and false. So on the alien side of things, because we're reading from the outside in, the false appears on the outside. So, the aliens I designed, didn't really design them, but the aliens in my thought processes were very symmetry oriented. They don't make a lot of distinction between left and right, front and back, top and bottom. Inside and out are the most important things to them. So, I thought that'd be nicely alien and hard to understand if you didn't know what you were looking for. So here's what the first message looks like transcribed. So like I said, it's tones, and so I'm not going to, part of the game wasn't going to be playing tones for people. It'd be too hard to work with them. So I said, well, here's a transcription of the tones. There were 10 messages in all. The 10th message, you're going to see later in this talk, sometimes it's 9, sometimes it's 10. There were 9 big messages. And then the 10th message was just 3 characters long. So sometimes people don't count the 10th message. This is the first one, like I said. There are 571 tones that make up the message. I assigned each tone to a different letter, with A being the lowest frequency tone, B being next highest, C being the next highest, and so on and so forth. Um, Although there are 571 tones in this first message, there are only 19 unique ones. So there's a lot of repetition. And we'll talk more about the tones in a bit. The puzzle itself, I launched on the web at the very end of January 1995. And the idea was that it's a message we've received from aliens from the star Tau Ceti, which is 12 light years away. We need to translate them. And the game part of this was not just, hey, try to translate these messages, but I wanted it to be collaborative. So it was a puzzle plus a message board. Possibly one of the earliest message boards on the web. I'm not going to claim the earliest. And certainly there were lots of message boards before that off of the web, like old style bulletin board systems and things. But this was probably a pretty early web forum posting area. Anyway, web games in those days were simple. So, like I said, I was kind of hoping to show that even if we got messages from aliens, and even if the aliens wanted us to translate them, it would be really hard to do so. They would be alien. So, how does somebody get these messages out there? How does somebody get players of this game? So in those days, there was a website that listed new websites. Um, it was possible to do that because there just weren't a lot of websites around. You could, if you had the time, maybe see most of the web if you followed this page and followed all the links that were posted to it every day. So I submitted my new game website to the web What's New page, and on thanks to the magic of the Internet Archive, we can see the posting that was there on February 8th, 1995, which is 30 years to the day of the day that I'm recording this, February 8th, 2025. So this is kind of the 30-year anniversary of this game. And the game, as you can see, was called the Contact Project. Um, so, like I said, in those days, this is how people found out about new websites. And a pretty big chunk of people who were on the web at the time would actually see it. Doesn't mean they would actually, go to it, but they would see it. And this is the website itself in all of its glorious 1990s design. It is still there. It's not active. You can't post anything on the message board, but it's all still there. So let's take a look at the message itself a little bit. I've broken the first part of it down here for you. This is just the first part of the first message with a little bit of formatting. I didn't, when we saw it on the earlier slide, it was all kind of mushed together. So the G character was the first thing that people figured out because it always appeared in pairs, except the very beginning of the message was one G and the very end of the message was one G. But every time you saw a G in between, there were always two of them. And so what the players figured out was that these are kind of like begin and end markers of each statement. Because that's how it would work. If you had a G at the beginning and end of each statement or each sentence, perhaps, and you line them up, then every time you would see a G somewhere in the message, it would be in pairs. But at the very beginning and very end of the message, there'd only be one. So they figured that out. So here, what I'm doing is breaking it down for you into the first few statements. And so you can see that, this is kind of interesting. It's basically just the letter B, so it's the second highest tone. And it basically just keeps increasing in each statement. First there's one, then there's two, then there's three, four, five, six. And so that was the next thing that the players figured out was that, well, this is kind of counting. It's teaching us that B seems to kind of represent the number one. And it's showing us how to count. Then the next part of the message looks like this. And so it uses G and B, and we already know that G is like just a message separator, a sentence separator. B is the number one, but we don't know what H is yet. And so the question is, can you figure it out by example? So you've got, and remember, we read from the outside in, but the players didn't know this. But what they could see is that, well, in that first sentence, there's a one, a two, and a one, and these H's. Well, it doesn't really tell us very much yet. But the next one is a two, a three, and a one, a three, and a two, a one, and then nothing on the other side of the H, or nothing, a one, and a one, and then on the last line, a two, a four, and a two. And so basically, that was enough examples that when they started sort of noodling on it and thinking about it for a bit and trying to figure out, well, the aliens started with counting. We're probably going to do some more basic math. It didn't take them long to figure out that the H was a plus. And as soon as you understood that, then they started figuring out the outside in grammar style. So that was actually discovered pretty quickly, which surprised me. Here's what it is then, like actually semi-translated, which I probably should have shown you while I was reading them out. And basically, the message goes along like this, introducing new symbols by example. And the more examples and the more new symbols you find, the easier it is to start translating the rest of the message. However, I started making the messages more complex as time went on. You have to start simple in your message to build up a vocabulary and try to make it as obvious as possible. So eventually I covered things like, chemistry, light, temperature, planets, molecules, time, speed, and so on. I introduced modifier symbols, so it would turn something into like an adjective. So if like I had trying to think, if I had a symbol that represented light in general, then the modifier adjective might change it to the word bright, or something like that. Anyway, so like I was saying, it got more and more complicated over time. And the last message, the last big message, the ninth message, had built up so much vocabulary by that time that I was able to write something of like an alien creation myth in that final message. Well, again, the final message was the 10th message, which was just 3 characters, which I'll tell you, it was like G, can't remember what the middle character was, and then G, and the middle character represented a question. So basically, the 10th message was just question mark, like, are you responding, kind of thing. Um, anyway, here's a screenshot of the message board. It was not a complicated message board. It's very linear. Just the messages get listed chronologically, and there was like a form to add a message. And if you clicked on one of the links, you see the message. It ran from, so this is just like the first few days of the game. It ran from the end of January 1995 until the end of June 95, so about 5 months. And there was really good collaboration. Like a bunch of people saw it and joined from the What's New page. People wrote software to help translate the messages. Other people created websites where they started like listing all the discoveries that have been made so far about the aliens. Somebody posted the actual tones of what it would sound like, because I also posted like what the actual frequency was of each tone. So somebody made an audio file of it. The message board was very, very active. Like I said, the symmetrical grammar was deciphered pretty quickly. And so instead of proving how hard it might be to understand aliens, I think I accidentally proved that how smart people in large groups collaborating over the internet can be pretty powerful. There's a saying sort of like, with enough eyes, all problems are shallow ones. And that's sort of what happened here. All 9 messages, and I guess the 10th micro message, were all translated fully at the end. Like every character was understood, every sentence was understood and had a description around it. And they were all pretty basic and straightforward. I mean, like I said, they got complicated, but the way that, for instance, the arithmetic worked, like that's kind of how everything worked, by example. And so nothing required you to like go through weird convoluted hoops to explain something. In fact, sometimes the game players caught me in errors. So they would find problems in the messages, like maybe where I did the math wrong or something. And so then, of course, I would apologize. I would post a message and apologize and say, I just transcribed it wrong. I'm fixing it now. Um, Now I'm making it sound like I was trying to convince people that it was real, and that's definitely not the case. If you go to the site, there's like one of the top links on it is why are we doing this, and that's kind of like an early frequently asked questions page. And when you go to it, the very first question is this real? And the answer is no. This is a game. We're doing this for fun. Um, Over the years after this, once the game ended, like I said, 5 months and all the messages were translated. Over the years, I would get emails from people who had just stumbled across it and decided to like try translating it themselves without looking at any of the discussion, and were having fun. Sometimes I would get a message from a teacher who would say, "Hey, I want to use this in a lesson plan," because you had to like, especially the first message, you had to be able to understand math. And then I would also occasionally do searches to see if anybody was linking to it or just talking about it. So on one of those searches, 15 years later, I did discover someone linking to and talking about it that I hadn't noticed previously. And it was pretty weird. And that's what the rest of this talk is going to be about. I just wanted to give you the background of what this game was. So let's talk about what I discovered 15 years later. These three gentlemen are all from the American Southwest. Jerry is a comedian and a radio show host. Rod, a reverend and a sci-fi and fantasy writer. Mostly I want to talk about the guy in the middle here, Wes Bateman. So he's the source of some interesting ideas that we're going to talk about. But I mentioned Jerry and Rod because they helped Wes spread these ideas through their websites and their networks. So Wes is a PhD in math, and he was a researcher of what he would call sacred geometry of the Egyptian pyramids, and invented something that he called the Ra system of mathematics. Ra, as in the Egyptian sun god Ra. Um, I'm sure he wouldn't say he invented it. He'd probably say he rediscovered it. So he also claimed to be in telepathic contact with aliens throughout various parts of his life. During the 1960s, according to Wes, he became a major source of inspiration for the producers of Star Trek, and in particular Gene L. Kuhn, who, along with some other Star Trek writers, attended Bateman's UFO lectures and cribbed ideas he had discussed, such as wormholes and warp drives, not to mention the Prime Directive, and incorporated those concepts into the Star Trek television series, at least according to Wes. So in 1997, which was about 2 years after the game, his niece sent him a link to the game and showed him a link, also another link to the game that was from the SETI League website. And I think Wes misinterpreted the SETI League as the SETI Institute, which is the one that was the actual NASA partner. And so I think that gave the link to the game some more gravitas than it maybe deserved. So he believed, and we'll get to why in a minute, that the game was actually a cover story. And so in reality, he thought that the government or some other organization had actually received messages from aliens, and they were unable to translate them. So a brilliant and nefarious move was made to get the public to translate the messages for them and claiming it to be fiction the whole time. So when I discovered this and discovered his web pages talking about it, um, it was funny at first, and the more I discovered, the less funny it became. He did work on this a lot. I discovered hundreds of pages of information from him online, along with a few hours of audio interviews from various conspiracy loving radio shows. He had felt we got the translations all wrong, and he was presenting his own research, his own translations. And it looks to me like he spent about a decade on it. So, like I said, funny at first and then depressing the more that I found. Here's an excerpt from his open letter to me, challenging me to come clean. Needless to say, I never saw this when he posted it. I only discovered it years later. I don't know why he didn't send it to me directly. There's another webpage where he tries to identify which of the many David Levines I am, because I have a common name. And it actually looks to me like he probably got it right. He knew that I was that he knew that I was the David Levine that worked at Johnson Space Center. Although he thought I worked directly for NASA, but like I said earlier, I was a contractor. And that clearly would also lend this whole thing a bit of gravitas that it didn't deserve, right? So let's take a look at the letter. I'm not going to read the whole thing to you, but I'll read a little bit. You, Dr. David Levine. First of all, thanks, Wes. I'm not a doctor, but I'll take it. You have claimed that you are the author of 9 fictitious extraterrestrial messages, which you posted on the internet as an experimental game in January 1995. We are openly challenging that claim and categorically state that these messages are real. We want to point out to you that we have found overwhelming discrepancies in your claim of authorship. Our extensive studies on these 9 ET messages have convinced us beyond a shadow of a doubt that you did not create them. We propose the following exercise if you wish to prove your claim to authorship. All you need to do is demonstrate how sections 7, 8, and 9 of message 1 were written, what they're supposed to reveal, and what the data in those sections actually relate to. We have already translated these sections and would like to compare what we have learned to whatever you claim is nothing more than data you've made up out of thin air. It goes without saying that as we publish more information regarding what we've learned about and through these messages and how we arrived at our conclusions, it will be easier for you to pretend that you created them. Therefore, it is necessary for us to demand that you immediately provide for publication your version of the data that is found in the 3 sections as identified above. If you, in fact, are the creator of these messages, then providing such a description should be a piece of cake. Logic dictates that it should not take much more than a few minutes of your time to jot down just what message and or meaning you wanted to convey in these fictitious sections. If you do not respond to our challenge within 1 week of this publication, we will assume you are making a silent statement of no contest. So first of all, there's some interesting assumptions in there, right? Because what I would say was how the messages were created and what they meant was all there on the website. Maybe not how I thought it up, but all the translations are, yes, that's how it's translated. But he translated it a completely different way, and what he's expecting me to do is to come out and say, oh yeah, you're right, all the translations on this website that I said were correct are all wrong, and here's the right translation, and then it'll miraculously match his if I was the person who really wrote them, and if they were really from aliens, I wouldn't be able to match it. This whole thing just makes me aggravated. Let's talk about raw mathematics for a minute, shall we? So he published, I think, like 4 big printed volumes on this. There's a lot and lots and lots of web pages, just tons of information. Basically, he had measurements of various parts of the Great Pyramid at Giza. He was looking for interesting coincidences, right? Repeated ratios in the geometry and so on. And actually, in some cases, the architects might have purposefully planned for some of those repetitions. In other cases, maybe not. But Wes was looking for higher meaning. He was relating the pyramid's geometry to things in chemistry and physics, quantum mechanics, and so on. So he applied raw mathematics to the game messages and said that everyone else had gotten the translation wrong. As you saw in the open letter, he claimed the messages were real, and a secret organization unable to translate them had turned to the internet in order to distribute the work among many minds. His translation, which I'll show you bits of later, was a lot more convoluted rather than the basic counting and math. He claims, that to have discovered the messages in line with his own discoveries, the pyramids, crop circles. He even claimed that he had a videotape of a UFO blinking its lights somehow in time with these messages. Next, I want to play just a short little clip for you of Wes talking on one of these either podcast or radio show. I'm not sure where this is from. I won't play the whole thing, just a little bit.
Such as the message 1 has we have found the way that Project Contact, these people that, so when I refer to them, we're talking about the people that try to con us into thinking it was a game. They claimed that there was about 607 tones in message number 1. Well, we find that there are 607.5. Okay? So how did the extraterrestrials express that 1/2 a tone? Uh, uh, the reason why we were able to zero in on that is because in message one, section uh, 2 of message one, it speaks of a square that has a relationship to a circle that has a 60.75 diameter. Then when you move to section 3, it talks about a spheroid that has a 60.75 unit diameter. We also found uh, that there are, in one of the formats, raw formats, there's 607.5 feet of this particular type. In
So that's probably enough for now. I just wanted to show you that it's unusual and convoluted explanations. Let's let's take a look at the kinds of mistakes that Wes was making. So, I knew I wanted the aliens to use a base 6 number system. They weren't going to have 10 fingers like we do, and a lower number would be easier on the players than a higher number of fingers. So I wanted the tones themselves to be about half a second long. But I knew, of course, the aliens weren't going to use our measurements. It would be silly for it to be exactly half a second long. So I randomly shifted a little bit and I said that the tone lengths were 0.492 seconds long, that being whatever the aliens' like basic unit of time measurement was. Close enough. Then I needed to decide the frequencies of the tones. And again, I wanted to use base 6 numbers. So if you divide 6 by 0.492, you get 12.1965. And so that's what I decided would be the spacing in hertz, or cycles per second hertz, of the spacing between the frequencies of each tone. And the frequency of the lowest tone, A, is that interval tone, 12.1965 hertz, times 6. You can't have the bass tone be 0 hertz, so I had to start it at the first interval. I guess I could have started it at 12.1965 hertz, but that's kind of low audibly. And I wanted it to be at least a little bit more interesting to play if somebody had made an audio version of it, which someone eventually did. I was originally thinking I might do it myself, but I didn't wind up doing it. Anyway, I'm not claiming that any of this is easy, but the derivation of these numbers is very easily explainable. Right? Like you can do this math now that I just told you about 6 divided by 0.492, and you get 12.1965, and it's the difference between each of the tones. The first tone is that 12.1965 times 6. Very, very straightforward, very simple. Um, Maybe not simple to discover, but once I explain it, it's like, okay, these numbers make sense, right? So let's see what Wes had to say about these frequencies. So he basically said that the frequencies were wrong, and he started changing them. He had very convoluted explanations using things like the Rydberg constant for infinite mass or the wavelength of the most intense spectral line of hydrogen. The values he wanted these numbers to be were not the values I posted. So I suppose he assumed that because these were signals from real aliens, maybe I mismeasured the frequencies. So he was happy just simply changing them to nearby values. In his writings, he frequently changed facts listed in the game, such as the frequencies and times of the messages, in order to better match his theories. This is just one example of many. He claimed that he actually claimed that I must have well, one of the explanations he gave was that I might have been trying to obscure the true message. Although, why I would then try to get the internet to decipher them if I wasn't giving them all the information doesn't make any sense. He actually claimed that no one could be as much of a genius as I'd need to be in order to create these messages that lined up so perfectly with his raw mathematics. Another little interesting claim I want to talk about was the thing where I say, you can see the text here, each tone was 0.492 seconds long, and I said plus or minus 5%, pretty much randomly. So I wanted the aliens to be a little bit lower tech than us as well. So I figured their radio transmitter would be mechanical and that the timing might be affected by the rickety machinery, and that their lower level of tech would eventually come through in the messages themselves. So some of the things that they say might be have different explanations for science than we do. They might be a little more just behind us in general. However, he said that this was one of the smoking guns. He says, if these messages were made up, why not say that each tone lasted exactly 0.492 seconds? But then again, as you will soon learn, this is not a game. So apparently in fiction, you're not allowed to throw in any little detail that makes things more believable and interesting, which in a game is called flavor text, by the way. Actually, this isn't even flavor text because I thought it might be a clue that would help decode later parts of the messages. His requirements for a game are sterile and exact. I also want to point out this little tidbit. Uh, Wes's disbelief at the mere suggestion that I could have known all of these things, like the Rydberg constant for infinite mass and so on, is kind of funny. But I didn't know all of those things. My numbers were not the same as his numbers. He literally was changing my values. So I want to focus on the 0.492 seconds a little bit more. First of all, he actually says the aliens would probably have preferred to use 0.0492 instead, but thought it might be too small for us to measure. But that's a 20th of a second. I would feel sort of insulted if aliens thought we couldn't measure a 20th of a second, wouldn't you? Anyway, so going back to not 0.0492, but 0.492, he felt that there wasn't just a single time unit of 0.492 seconds. He felt that there were two very similar time units used, 0.492 and 0.494 or 4938, here. And he thought that more information would be encoded by which time unit was used. So some tones were 0.492 seconds long and some tones were 0.494 seconds long. But first of all, if that's true, the fact that I didn't report those precise times would make it impossible for him to ever get any information out of that. And second, he thought this might explain the fact that I said the tone length varied by around 5%. But I'll point out the difference between these two values is less than 0.5%. So for somebody who has a PhD in math, the most important thing here, though, is the second value, the 0.49381. It's a ratio that comes up somewhat frequently in raw mathematics. It's a ratio that came from like measurements of the Great Pyramid. So again, this is not my value of 0.492, but this is still the very first thing that Wes noticed when his niece sent him a link to the game. He noticed the 0.492. It triggered in him this ratio in raw math. It might have just been a coincidence. It was, but it got him interested enough to dive deeper. So without this coincidence, he might have just decided to ignore the game entirely. And that first coincidence led him to a second one. So there's this prominent set of numbers in raw mathematics called the raw table of nines, and it has 37 entries in the table. So a little way back, I told you that the first message had 571 characters in it, and it used 19 unique characters or tones. The second message, out of the total of 9 big ones and 1 little one, the second message introduced 18 additional new characters, unique characters, into the vocabulary. So if you look at the first and second messages and ignore all the rest of the messages, there are 37 unique characters. And the raw table of nines has 37 entries. So this coincidence was enough to convince Wes that basically was the real smoking gun. So the 0.492 and the 37, basically, as far as he was concerned, these messages must have been created with raw math. And, quite correctly, he felt like there was no way I could have known about raw math. Yes, correct. I would not have known about raw math. So remember that just a minute ago I showed you the statement of his disbelief. So now that's starting to look a little bit more understandable, right? These two coincidences, they convinced him that raw math was underpinning these messages. And then so he started changing numbers to more closely match raw math. And once you're convinced that raw math was used, it makes total sense that I couldn't have made up the messages. So have you ever heard the phrase, you can't make this stuff up? Well, you can't make this up. Wes thought I couldn't possibly have made that stuff up. So once Wes was convinced, he was able to start manipulating my numbers, sometimes in small ways, to match raw math. How is that possible? So to put it simply, he had an embarrassment of riches. The raw table of nines may have 37 entries, but each entry has three values. So there's 111 numbers right there. He also had my own numbers, just like all the frequencies and times that I listed, the lengths of the messages, the numbers of unique characters, and not just looking at the first two messages like he did with the 37. There were 10 total messages, so he could look at the first two in combination, or he could derive more numbers by looking at any groupings of messages in any order. Maybe look at all the even messages, 2, 4, 6, 8, and say, okay, how many unique characters are in there? And that's another number that you can work with. And like I said, he had no problems editing my numbers a bit when he needed to, and that gave him more data. But he had a massive amount of data to work with in order to find relationships between the messages and raw math. So the coincidences that he found seemed incredibly unlikely to him. So he decided that they weren't coincidences. But just how likely or unlikely were they, really? Let's find out. So there's this problem in statistics called the birthday problem. You might have heard of it. If you have, just stick with me anyway. If you haven't, you might find this interesting. How many people are needed in a room so that you have two people who share the same birthday? Let me give it to you a different way because the math is going to get to be a little easier. What if I just said I want a 50-50 shot? I need enough people in the room where I've got a 50% chance that two of those people share a birthday. How many people need to be in the room? Would you think, well, half of 365 or something like that? No. You just need 23 people in the room to have a 50-50 shot at two of them sharing a birthday. So, how does that work? Well, let's start by saying that there are only two people in the room. So, what are the odds of just two people not sharing a birthday? Well, the first person, their birthday gets to be on any day of the year. The second person, their birthday can, oh, I'm sorry, I'm flipping it around. Skip that part. It's going to be easier for us to talk about what are the odds of them not sharing a birthday. So for them not to share a birthday, that second person, their birthday can be on any of 364 days out of the year. If they're on that same day, then they are sharing a birthday. So you can see, I hope, pretty easily that the odds of the two people not sharing a birthday is 99.7%. Now, why did I do it that way? Why did I flip it around? So the math is a little bit easier because we can now just say, well, there's a 0.3% chance that they share a birthday, basically 100 minus the 99.7. So let's take a look at what happens when we add a third person into the room. So now that third person, the first two people, they each have a unique birthday. How does the third person have a unique birthday? Well, their birthday can be on any one of 363 days of the year. If they're on the other 2 days, then they're going to match somebody. So when we have three people in the room, the odds that all three of them have totally different birthdays is 99.2%, which means that there's a 0.8% chance that two of them are going to share a birthday. Or two or more are going to share a birthday, probably. So what about four people in the room? Well, the fourth person can have their birthday on any of 362 days out of the year. Odds of everyone having unique separate birthdays is 98.4%, and the odds of two of them sharing a birthday is 1.6%. And so we can keep going. If we keep adding people to the room, when we get to 23, that 23rd person can have their birthday on any of 343 days out of the year. We multiply all those numbers, all those ratios up together, we get 49.3%. So there's a 49.3% that those 23 people all have unique birthdays, which means that it's now slightly over half. It's a 50.7% chance that two of them share a birthday. Just out of interest, if we go up to 50 people, the odds of having unique birthdays among all 50 people is only 3%. So 50 people in a room, there's a 97% chance that at least two of them are going to share a birthday. So let's talk about something else, something maybe that you might not have heard of. The birthday problem some people have heard of. So let's talk about, let's imagine that there's a disease that 1% of the population has. And there's a test, a medical test to see if you have the disease, and it's 95% accurate. And so what does that mean? What does 95% accurate means? Well, let's say it means that 95% of the time when somebody has the disease, the test will show positive. And 95% of the time when someone doesn't have the disease, the test will show negative. Great. So if you test positive, what are the chances that you have the disease? So this is called the positive predictive value of the test. Because as a patient, I don't really care what the accuracy of the test is. What I care about is, okay, I tested positive. What are the odds I have the disease? It's not 95%. What is it? So a lot of people think when they're told, well, it's not 95%, that, well, it must be something high, right? But the positive predictive value is 16% in this case. This test that's 95% accurate, if you test positive, you only have a 16% chance of having the disease. Why? Let's imagine we've got 100 people and one person has the disease. We said earlier 1% of the population has the disease. Now, if you want to be a stickler about this, if I picked 100 random people, um, just because 1% have the disease doesn't mean my 100 randomly selected people will have one person with the disease, right? Like sometimes I might have a random selection where nobody has the disease, or sometimes I'll have a random selection where 4 people have the disease. But the idea is that on average, over time, selections of 100 people will average out such that one person has the disease. So let's say we picked a nice, perfect selection, random selection of 100 people. One person's got the disease. We don't know who it is. Anyway, that person takes the test and it's 95% accurate. And so 95% of the times when somebody has the disease, the test will show positive. So the test shows positive for this person. Great. Well, not great for that person, but great for the math. So the thing is, remember that we don't know that that person has the disease yet. That person took the test, sure, but we didn't know who out of these 100 people had the disease. All 100 people take the test, and the test is 95% accurate. So let's assume out of the other 99 people that 5 people who don't have the disease test positive for it because the test is only 95% accurate. So now we've got 6 people who have positive tests, but only one of those 6 people has the disease. That's where the 16% comes from. And hopefully that makes sense. Um, the other thing I wanted to point out is that if you have symptoms, it totally changes the math here. So we're talking in this case, this is sort of like a nice pure math case where 1% of the population has the disease, but there's no outward signs. There's no way for us to know. So we're testing everybody. If you had a disease that one of the symptoms was it turns your skin purple, we're clearly only going to be testing people with purple skin to see, and so that'll change the stats. But again, I think my point here is that some of this stuff is not really intuitive, and I kind of want you to understand that and see how it actually works. Now, this was kind of theoretical. I'm just going to mention really quickly an actual real world example of this, which was the National Lung Screening Trial. They had 50,000 participants over 3 years, no symptoms, heavy smokers, looking for lung cancer. They used low dose CAT scans. And their tests, if you had cancer, it was 93.8% accurate at detecting it. And if you had no cancer, it was 73.4% accurate at saying that you didn't have cancer. So the positive predictive value of this test is 3.8%. If you went through the National Lung Screening Trial and said you had cancer, you really only had a 3.8% chance of actually having it. Even though the accuracies of the tests are pretty high looking. So this leads to lots of unnecessary diagnostic procedures. Let's look at another example. Let's say I have 100 people here and 10 of them are highlighted in red. Let's say these 10 people have some kind of specific belief, but I don't know any of this. I want to find out what percentage of the population has this belief, whatever it is. But let's say 100 people is too many for me to ask everybody. So I'm going to take a sample. How big my sample is and which people I randomly select to talk to is going to matter a lot. So let's say I'm going to use a sample of 20 people, which is 20% of the entire population, which is actually a pretty big chunk. It turns out each row here is 20 people, so it's going to make this nice and convenient for me, but didn't have to be that way. So let's look at the first row. My sample size then is 20 people out of the full population of 100, and my measurement is, well, 1 out of 20 people here, or 5% of the people in this row, have this belief, because I ask all 20 people and one person says, yeah, that's what I believe. Um, we know, of course, this is just an estimate, right? We're only asking 20 people, and we're trying to kind of extrapolate that to the rest of the population. And so, a really simple way of doing that is just saying, oh, well, it must be 5% for everybody then. Hopefully, this is a representative sample. But it's not. I mean, it is in some ways, but it's not good enough. And so there is statistical math that will tell you exactly how confident we can be in those numbers. And I'm not going to bore you with the math. I just want to show you what the results are and what they mean. So if we want to say that we want to be 95% sure of our result, that 5% of the population has this belief, then my confidence interval works out to be 8.6%. What does that mean? What is a confidence interval? So what this means is that I'm 95% sure that the true value will be 5% plus or minus 8.6%. Now, 5 minus 8.6 is a negative percentage, so I'm just going to call it 0. So to put it another way, we're 95% sure that the true value for all 100 people is going to be between 0 and 13.6%. But we're only 95% sure. There's a 5% chance that the true value is outside of that range. That's not nothing. That's a 1 in 20 chance that the true value could be, for instance, 80%. And which 20 people we choose to survey matters a lot. Let me give you the data if I looked at each row. So if I randomly selected the 20 people in the third row, my answer would have been completely wrong. The true value overall out of all 100 people is 10%. But my survey of 20 people, if I looked at the people in the third row, my surveys would have said it's 30%, and the confidence interval at a 95% confidence level is 12 to 48%, which is pretty wide, first of all. But the true value of 10% doesn't even fall in that range at all. So let's say I'm doing this with 20 different surveys with different groups of people and different questions, and I report back to you data like this. Like each one is a single question, and I've got 95% confidence level with confidence intervals. So when there's a 1 in 20 chance that each one is outside the confidence interval, what are the odds that at least one of those 20 surveys is just wrong? It's pretty high. I actually don't know the math to say, okay, with 20 surveys and a 1 in 20 chance of it being wrong, it's not 100%. I know that. But it's a pretty high percentage that one of them is going to be wrong. I'm not a mathematician. I'm not a statistician either. Uh, and again, I'm not asking what are the odds that all of them are wrong. I mean, with 20 tests, the odds that all of them are wrong is pretty unlikely. But what if one of them is wrong? It's pretty high. Which one? Who knows? It could have been any one of the 20 surveys that could be the wrong one. Um, so let's move on. I want to talk about this book, The Bible Code. This is from the 1990s. And it basically, the author, Michael Drosnin, his sort of statement here was that the Bible contains messages from God. Wait a second. I guess that's the point of the Bible. What Michael Drosnin was saying is that the Bible contains hidden messages from God, predictions about the future, hidden in skip codes, which I'll explain in a second. And actually, Michael Drosnin is apparently an atheist, and he actually believes that these messages were embedded in the Bible, not by God, but by time traveling aliens. Anyway, let's look to see what a skip code is and how it works. So first I'm going to show you the very beginning of the Bible. So this is the first 10 verses. It's not a lot of text. The first thing I'm going to do is I'm going to make it all uppercase. And then we're going to remove the punctuation. Then I'm going to remove the spaces. And then I'm going to change the font to be monospaced so that all the letters line up nicely. And then I'm going to put them in a grid. The grid here, I'm wrapping at 45 characters. So the width of the grid is 45 letters long. So what a skip code is that it means that you can pick out, say, every 10th letter, or every 15th letter, or every 20th letter, or something like that. And when you extract the letters out by skipping over the other letters, you get a completely different message, a completely different story. So I've wrapped this at 45 characters. That means if my skip code was 45, the letters would be in a nice, perfect vertical line. This is starting to look like a word search game, right? It kind of is. It's actually easier than a word search game in some ways because, well, I'll show you in a second. So anyway, here's a word, nerd, right there in the Bible with a skip code of 45. We're skipping every 45th, we're skipping every 45 characters to pick a letter out, and we make the word nerd out of it. Part of the book, the Bible Code, though, is not just about finding words. It's about finding a bunch of words that are related to each other, close to each other in the Bible this way. Here's another word with a skip code of 134, herd. So I was saying it's a little bit easier than a word search puzzle because in word searches, the letters have to be directly adjacent to each other, either up, down, left, right, or diagonally. But with skip codes, they're diagonal, but they don't have to be like on the next line. They can skip lines. It's totally fine. I want to point out the fact that this diagonal exists this way and it skips lines. If I wrapped the letters at 134 characters instead of at 45 characters, then the word herd would line up perfectly vertically, just like nerd did. And in fact, if I wrapped it at 134, nerd would now be the one that's at an angle. But this is totally legal in Michael Drosnin's book to do this kind of thing, to mix skip codes together. Here's another word, the word here, skip code of 3. Here's the word room with a skip code of just 2, every other letter. Here's the word site with a skip code of -44. Instead of reading down, it's reading up. But you can do that in word search puzzles. Here's the word now with a skip code of 55. Here's all of them. There's a nerd herd here in this room on this site right now. And this is the first 10 lines of the book, of the Bible. Let me point out also, the nerd herd here in the room right now, it's just me in the room, but I originally gave this talk in a room with an audience. So I didn't want to redo this. So anyway, this is kind of how the Bible code works. Michael Drosnin, though, didn't use 10 lines of the Bible. He used the entire Bible. And he also worked with it in Hebrew. So there's 300,000 Hebrew letters in the Bible. And interestingly, this form of Hebrew uses no vowels. So imagine if you were to write English with no vowels. A lot of words could be interpreted as other words as well. It makes it a lot easier to find words. Just like a word search puzzle, you can go forwards or backwards, up, down, left, right, diagonally. But like I said, it's more flexible because you can get these disconnected diagonals as well. And I just want to point out, this is like an interesting one, right? Twin towers, it knocked down twice, airplane. Just like Wes Bateman felt like, hey, this is pretty unlikely stuff when he said that, that the message was clearly made with raw mathematics. Michael Drosnin looks at this and says, hey, this is pretty unlikely. But he hasn't done the math or the science to determine how unlikely is this. So I wanted to show you something pretty interesting that a lot of other people have done is they've started looking for these codes in other books. This isn't the Bible, this is Moby Dick. And what someone found here is a bunch of words right next to each other, crossing each other, talking about the assassination of Yitzhak Rabin in Moby Dick. It turns out you can do this with purely random text as well. As long as the letters have like English frequency distribution, it'll work and you can find things. And I want to point out, it is harder in English than in Hebrew because we've also got the vowels. So this is called apophenia, which is when you see patterns that don't really exist. Apophenia is something that like our neocortex does, and it's actually super useful. Well, not apophenia, but the pattern matching is super useful. We don't want to find patterns where they don't exist. We want to find patterns where they do exist. Our brains are really good at finding patterns. It's good for hunters, right? It's good for avoiding predators or poisonous plants as long as you like recognize the patterns. But when we're intuitively bad at statistics, we think things are rare that are not, and we see patterns where they really aren't. It's never notable when likely events happen, so you really just kind of notice when unlikely ones happen. Let's think about the lottery for a second, right? The odds of you winning the lottery are pretty negligible, I'm sorry. But the odds of somebody winning the lottery, of the lottery being won, is very high. Happens almost every week. So the Bible code, 300,000 Hebrew letters, no vowels. We saw it wasn't even any problem when I did it with vowels, and just the smallest part, 10 lines of the Bible. Is it really that amazing that he found weird coincidences? Does this distribution of dots look randomly placed to you? What about this distribution? Let me go back to the other one. And then this one again. This is the random one. It's people tend to think that, oh, this that randomness should be spread out, but it's not. Randomness has clusters in it that happen. There's groupings. In fact, the other image is made from this image, but just removing the dots that are too close. But randomness has clusters, and clusters make patterns. And so this to me, like if I squint a little bit, it almost looks like two people dancing. So what does that remind me of? Dots making patterns that I kind of recognize and I see interesting things in. Oh, yeah. Guess what? Constellations are not real. I mean, the stars are real. The cultural stories we tell ourselves about these patterns are real, but nobody put stars in these positions. The Big Dipper is not there to be a Big Dipper. We just agree on the patterns we see. Nobody put stars in those positions to be those patterns. Do you see something? Do you think that there's something there to be seen? Or is it just a cloud that happens to look like something, like a person striding through the clouds, maybe with a big backpack on? So this is from one of my favorite websites, Spurious Correlations by Tyler Vigen. I'm not sure how to pronounce his last name. I'm sorry. Spurious correlations exist everywhere, all the time. This is so the x-axis here is looking for each year, and it's comparing how many letters were in the winning word of the Scripps National Spelling Bee that year with how many people were killed that year by venomous spiders. And these curves are really close together. If I saw that and if I saw a graph like this and the two things being compared were something like more reasonably potentially related, I would say, oh wow, yeah, that's, or maybe not reasonably related, but some kind of conspiracy theory, I would think, oh yeah, that pattern, that match is amazing. But I hope that nobody watching this thinks that there is any relationship between the number of people killed by venomous spiders with the number of letters in the winning word of the Scripps National Spelling Bee each year. Here's the divorce rate in Maine lined up with the per capita consumption of margarine each year. And again, they're pretty close. And another one that looks amazingly close. Each year's age of Miss America correlating with the number of murders by steam, hot vapors, and hot objects. So this is funny, right? Like that stuff's pretty funny, but it's also a problem. The more data we have, the easier it is to find patterns like this. Correlation between two measurements doesn't mean that there's a causal relationship between them. So how do we get around this? How do we solve this? How do we stop ourselves from being fooled by these kinds of patterns? Science. But do you really know what science is? We think I mean, we know what science is like. It's like people in lab coats with like beakers and stuff, right? But we learned what science actually is back in middle school. Do you remember? Science is a process. Do you recall the scientific method? So the scientific method usually starts maybe at the top. You make some kind of observation that leads you to a question. You create a hypothesis of how to answer that question, and then you perform an experiment and gather data. And you analyze your data, you come up with a conclusion, and maybe your conclusion leads to additional observations, and back on the cycle you go. This is science. I want to focus particularly on hypothesis and a little bit probably on experiment. Um, Hypotheses have to be falsifiable. So what does that mean for a hypothesis to be falsifiable? It means that you have to be able to think of a test of your hypothesis where you can imagine an outcome where your test shows that the hypothesis is wrong. If you can't, then it's not really testable. Here's a hypothesis that's not falsifiable. No planet anywhere in the universe is made of Swiss cheese. It's not falsifiable because we would have to examine every planet in the universe. Yes, it's a ridiculous ridiculous hypothesis. And I think we probably all agree that it's true. But that's still not a falsifiable hypothesis. We could make it falsifiable by narrowing the scope. For example, I mean, we could say that there's no planet within 10 light years of Earth that's made of Swiss cheese. Now, it would take better telescopes than we have today. So it would be years before we could even hope to start reliably gathering data and by first finding all the planets within 10 light years. But at least it's something that we could potentially do. What if my hypothesis is that there are microchips in vaccines, but they're too small for anyone to detect, even with a microscope? Well, if I tell you there's no way to detect them, there's no way to verify it, that's not a falsifiable hypothesis. It's not science. You have to take it entirely on faith. And I'm not saying faith is worthless. I'm just saying we should never confuse faith and science. We always need to be clear about which is which. How could Michael Drosnin have made a falsifiable hypothesis and tested it? Instead of saying that there are skip codes in the Bible that reveal secret messages about the present or the future, he could have said, and you cannot find these messages in any other book besides the Bible. That would have been a falsifiable hypothesis, and it would have been falsified. So, yeah. What about Wes? He had his 37 numbers in the raw table of nines and the 37 unique symbols in the first two messages. Why the first two messages? Why not the first message or the first three or messages 2 and 4 and so on? You know, he could have, if it wasn't the 37 unique symbols in the first two messages, he could have, maybe there was some other number, like the total number of characters rather than the number of unique ones. Could have used any kind of combination. He was swimming in data. He did not have a falsifiable hypothesis either. He was just, sometimes it's called data dredging or p-hacking, where you're just looking through data trying to find patterns. And we pattern match really well, as I said. So it's the wrong way to go about this kind of stuff. So when I discovered all of this in 2010, there was a skeptic podcast that asked to interview me. And so I wanted to show how easy it is to fall into these kinds of traps and to find these patterns where they don't really exist. So I decided to take a look at Wes's early interest, the Great Pyramid at Giza, and I just took 30 minutes before the interview to find what I'm going to show you. So if you're susceptible to conspiracy theories, this is your warning to look away. You may never be the same. My non-falsifiable hypothesis is that the geometry of Manhattan is influenced by the ghost of the architect of the Great Pyramid, and I'm going to prove it. The slope of the Great Pyramid of Giza is at an angle of 51.8 degrees from vertical. If you go to the Empire State Building and you take a heading of 51.8 degrees from north, it gets you to Grand Central Terminal. The distance to Grand Central Terminal from the Empire State Building is 3,023 feet, which is also the perimeter of the Great Pyramid at Giza. If you look at the roof heights of the buildings, the Empire State Building and the MetLife Building, which is on top of Grand Central, and you divide them by each other, you get the same ratio as the width to the height of the Great Pyramid of Giza, which also happens to be half of pi. And bonus facts, the number of stairs to the observation deck of the Empire State Building is 500 pi, and the floor area of the MetLife Building is 1 million pi. My hypothesis, like I said, wasn't really falsifiable, right? It's an idea, and then I looked for evidence to support my idea by finding coincidences. I was data dredging. There are so many numbers associated with the Great Pyramid and so many numbers in a map of Manhattan. If I didn't find matches like these, I could have rearranged the numbers, maybe reversed the roof heights, and that would have worked in the ratio. Or maybe the roof height ratio could have been some multiple of the other ratio. Or maybe I would have had that angle lead to a different building. Or maybe the perimeter of the pyramid would have been half the distance between the two buildings instead of the same distance. I could have used completely different landmarks. I just have too many options here. And I can make it sound convincing. I hope you you agree that this is some pretty cool stuff. It's just, I hope you don't really believe that the ghost of the architect of the Great Pyramid at Giza has anything to do with how the map of Manhattan is laid out or the heights of the buildings. If you are interested in this kind of stuff, I want to make three book recommendations. One is Humble Pie by Matt Parker. It's funny. It's about math mistakes in the real world that have consequences, but it's not conspiracy theories. But maybe don't read it if you're afraid of flying. Um, there's also Weapons of Math Destruction by Kathy O'Neill. This is about misunderstanding data, either accidentally or purposefully, and its consequences, especially for those less fortunate than us. I really did like this. I listened to audiobooks of all three of these. And the Improbability Principle. This is a great accessible book by David Hand about how events that we think are rare often aren't. So sad that I don't have time really to show you so much more. There's more audio clips from Wes, from radio and podcast interviews. There's videos. There's this whole thing called raw music that you can look up online. There's lots more writing that he did. There's other people on the web discovering his stuff and writing about it themselves. When I discovered this in 2010, I had to decide, what should I do? Should I try to contact him? A friend, I think, suggested you could really easily make this hilarious and string him along and drop little hints about how close to the truth he is. But I'm not that kind of person. I would never do that. I mean, what would you do, right? And if you contact him, would he believe? Um, I didn't have to make that choice because I found out he had passed away really only a few months before I discovered all of this. So yeah, I don't know what I would have done. I think probably I would not have reached out, but you never know. This is Wes and his wife in 1963. I want to point out that Wes wasn't trying to trick anybody. He fooled himself. He took these two weak coincidences that only happened because he was data dredging. The messages, the data in the messages and the data in raw math, there's just a huge amount of random data. And so you're bound to find stuff. Remember constellations. He convinced himself, that raw math was involved here, and how on earth could I have written them then? You can see how easy that all of this happened by accident. I want you to think about how easy it would be to do this on purpose. So what have we learned? Well, understand that statistics can be non-intuitive. Just because you feel like something is likely or unlikely doesn't make it so. I've showed you some things that seem pretty unlikely and so must have had some kind of causal relationship. No, they can happen by chance. Unlikely stuff sometimes isn't. And I also showed you how even statistics that seem fairly easy to understand, like that 95% accuracy of the test, can hide some surprising things, like the 16% positive predictive value. Your hypotheses have to be able to be proven false, or they're just not science, they're not testable. And apophenia is a real thing that we all experience. Be skeptical in the face of conspiracy theories. Next time, I'll tell you about the time that Garry Kasparov tried to convince me that 1,000 years of our history are made up. Thanks for listening. Bye.